for keeping on following me now. We are going to look at the hands-on as far as testing for non-reducing sugars are concerned. Now, from the previous video, we have seen that for the case of the procedure here, we shall come and say to 1 centimeter cubed of the food solution. Hey, if you have some food and you want to carry out a food test about non-reducing sugar, you get that food, you turn it into a solution. So you have 1 centimeter cubed of food solution. We are supposed to add what? We add, Here we are going to keep on adding 1 until the end. So the next reagent is what? After having our food, 1 centimeter cubed of our food, what do we add? We add 1 centimeter cubed of what? Of which reagent? I hope you have said hydrochloric acid. Yeah. So we add 1 centimeter cubed of hydrochloric acid. Then what do we do after adding hydrochloric acid? We boil. So we shall say and boil. Then after, what do we do? We cool. Yes. We boil, and then after boiling, we cool the what? The mixture. When the mixture has cooled, what do we do? Then we add. Add 1 centimeter cubed of what? Of which reagent? Of sodium hydroxide solution. And please take note, we are saying sodium hydroxide solution. Here, I'm also supposed to add a word. We are supposed to also add a word of dilute hydrochloric acid, because this acid might be conc. We also have a conc one. So we are saying we add 1 centimeter cubed of dilute hydrochloric acid, and then we boil. Then after we cool. And then after cooling, we cool the mixture, then we add 1 centimeter cubed of sodium hydroxide. Then after adding sodium hydroxide, what do we do? After we have added sodium hydroxide, then we can add 1 centimeter cubed of Benedict's what? Of Benedict's solution, and we what? And we boil again, and then we now boil for what? For 1 minute. Yeah, some other people take it to another level and they boil for 2 minutes. Yeah. Of course, boiling for 2 minutes is to ensure that to be very, very, very confident. But if you are indeed boiling, if these things start boiling and you ensure that 1 minute has really elapsed when these things are boiling, you should be able to already have seen the observation. So in case you are a student and you have been following me, and then maybe in your book which you have and you are using for reference, you find that maybe they are saying 1 minute. Don't say, why are you saying 1 minute when for me in my book I have 2 minutes? 2 minutes, just that one ensures that indeed that you are very conk sure. But I'm saying that practically, if indeed your mixture is boiling and the 1 minute fully elapses, you can be able to see these observations. Of course, most of you usually even boil for a few seconds, for like 5 seconds, and then you say, yeah, I've finished. That is very dangerous. That's very dangerous. Yeah, so we are boiling for 1 minute. We are adding dilute hydrochloric acid. We are boiling. We are cooling. We are adding sodium hydroxide solution. We are adding Benedict solution, and we are boiling. So come with me here. If I now get my solution, I have my sucrose. So I'm going to turn this sucrose into a solution. So I'm going to turn this sucrose into a solution. So I'm going to pick part of this sucrose, and I make a solution. Out of it. So I have my test tubes are very clean. I already washed them. So I have my sucrose. From this sucrose, I'm going to obtain a solution. And this solution is what I'm going to use. So because sucrose is a disaccharide, and we said all disaccharides are soluble, I also expect it to be soluble here. So I'm going to have obtained crystals from sucrose. I've dissolved them in water. So I'm going to use this mixture here. It's what I'm going to use for my experimentation. Yeah, so after I have obtained my mixture here, I want to be sure that everything has fully dissolved. So after I've obtained this mixture of mine here, so I'm going to come and I pick a smaller sample. I'm going to come and pick a smaller sample. Yeah, I know some of you are saying you would like to always look at what I'm doing for step by step. So I'm going to come and I pick a smaller sample of this sucrose, and after picking a smaller sample of this sucrose, I have a smaller sample of sucrose. Last time I showed you how 1 centimeter is. 1 centimeter cubed, I told you it is around that. 1 centimeter cubed is around this size. Is around this size here. That's 1 centimeter cubed. Then I will come. I hope you have seen where I've put my mixture. Then I will come in this. This is my 1 centimeter cubed. I will come and also pick a smaller sample of Benedict solution, which is also 1 centimeter cubed. I told you in the first video we were able to see where 1 centimeter cubed always reaches. We are supposed to add equal amounts, an equal amount. So when you compare these two, I don't know. Yeah, when you compare these two, you see they are almost equal. I know somebody say, hey, teacher, you are lying. This one is slightly above. Maybe one for Benedict solution is slightly above. Is slightly above. Let me not put back at the other side, because this test you might be having some issues, and then yeah, I think now they are almost equal. Yeah, so I get this Benedict, I add it here in. This is just pure sucrose. I am adding just Benedict solution to show you that this sucrose is a non-reducing sugar. When I combine with the sucrose and I boil, if I combine and I boil, I don't expect to see any observation. Why? I expect the Benedict solution to remain when it is in its original color. Benedict solution I expect to remain blue because sucrose is a non-reducing sugar. Is a non-reducing sugar. So I don't expect anything to change in as far as this test is concerned, because sucrose is a non-reducing sugar. So if I get this mixture of mine, and I boil it here. If I get it and I boil it here, I do expect everything to remain. So I have my blue solution. When I boil it here, I expect it to remain blue. So focus your eyes on my mixture here. So I have my blue solution. When I boil it here, I expect it to remain almost the same. After boiling it. Yeah, so when you check this thing is already boiling, you see, it is boiling. But if it was having by this time, all the things would have turned. Yeah, so when you check, it is boiling, but when it is after boiling, you see nothing is what? Nothing is changing. Yeah, you see, here it is boiling. You see the fire is a serious one. I have a lot of fire here, but after boiling, you see that the solution is remaining. Yeah, the solution is remaining blue. So it means this is a confirmation that indeed sucrose is a non-reducing sugar. Yeah, you see. So after boiling, you see the order that means that there is some serious boiling which is happening here. You see, that's why you see that few molecules, the whole of it coming out there. So it means here, this is a confirmation that indeed sucrose is a non-reducing sugar. That's why there is no any change. It is still my blue color which I'm having here. So after we have confirmed that indeed sucrose is a non-reducing sugar, now we want to carry out this procedure the way it is here, and then we see if this sucrose is going to be able to be broken down to non-reducing sugar, and then we shall be able, and then we see the other colors we are supposed to see. So after we have confirmed that indeed now sucrose is indeed a non-reducing sugar, it has refused to turn Benedict solution to other colors. So what we do, we now follow this procedure, which procedure involves turning the non-reducing sugar into reducing sugar. So I will come and I pick my smaller sample again. I'll come and pick my smaller sample again. I'll come here and I pick my smaller sample again. So I'll come and I pick my smaller sample, which is equivalent to 1 centimeter cubed. I'll come and I pick my smaller sample, which is equivalent to 1 centimeter cubed. So if I come and I pick my small sample from a sucrose solution that I had prepared, if I come and I pick my small sample, like this sample here, I think this is not small, this is, okay, let me just use this. If I pick this small sample, then by procedure, we are supposed, I think let me reduce a bit because this one is likely to be too much at the end. Yeah, so I have a small sample, my small sample, which is like this, and then if we follow the procedure, I add 1 centiliter of Benedict's, of hydrochloric acid. So with this sample of mine here, let me first place it here. I have my acid. My acid, I told you my acid is here. So I am going to first put this one here. So I am going to pick a small sample. Let me first also wash this test tube here very well. Let me first wash this test tube very well. So I am going to come and I pick a small sample of hydrochloric acid. An equal sample, not a small sample, but I should ensure that this sample I'm going to put here is equivalent to what I've put the other side. So I will come and I pick, this is now hydrochloric acid, which is almost an equal sample, a sample which is equivalent to, so when you check here, these are almost the same. This is hydrochloric acid, this is the full solution. So I will get this acid and I pour. Let me add like 1 drop. Let me add like 1 drop to ensure that, So I will get this acid and I pour it here. So after pouring it there, I come and boil the mixture. Boil for the mixture. Also, preferably for like 1 minute or 2 minutes. So I will come and I boil this mixture. So as I'm boiling here, what am I expecting? I'm expecting that in the process of boiling here, as this mixture boils, I expect the non-reducing sugar sucrose to be turned into fructose and glucose. Which fructose and glucose are non-reducing sugars. Which fructose and glucose are reducing sugars. So here I am boiling them. So I expect that in the process of boiling, the non-reducing sugar sucrose is being turned into reducing sugar, glucose and fructose. So here I have boiled. You hope you can see this much fumes here. That means there's something which is happening here. We are boiling. So I expect that as I'm boiling, the non-reducing sugar sucrose is being hydrolyzed into reducing sugar, that is glucose and fructose. So after I've indeed boiled for 1 minute, after I've boiled for 1 minute, of course, 1 minute is almost ending. 1 minute is almost ending. So after I have boiled enough, like that. So in this case, I am sure that I can be sure that what I am having here is now my glucose. Which has what I'm having here is sucrose, which has been broken down into glucose, into fructose and glucose. So I expect to be having reducing sugar here. Then after I've done that, I'm supposed to cool. I cool the mixture. Make sure the mixture cools down. And after the mixture has cooled down, the mixture has already cooled. After the mixture has cooled, I come and I add sodium hydroxide solution. I come and I add my sodium hydroxide solution. Sodium hydroxide solution is here. So I will come and I pick a small sample of sodium hydroxide. Also 1 centiliter of sodium hydroxide. 1 centiliter of sodium hydroxide. So this is sodium hydroxide. I'm also trying to ensure that they are almost equal. If I get the sodium hydroxide, I told you it is better the solution remains which is alkaline than it being what? Acidic. So I get this amount and I pour it here. I come and I pour it here. Yeah, so when I pour it there, I am sure that now the hydrochloric acid has been neutralized. After that, then I get an equal amount of Benedict solution. I get an equal amount of Benedict solution. I get an equal amount of Benedict solution and I add. So I get an equal amount of Benedict solution and I add there. Equal amount of Benedict solution and I add it there. So yeah, I come and I add my Benedict solution here. So when I add Benedict solution, I hope you see I have a blue solution here at first. So after having a blue solution now, so when you are writing, you don't have to tell us about all the other colors we formed in the middle. I know some of you could have said, you see, we saw some colors, yellow color, what. No, we don't need all those colors that we formed in the middle there. We don't need them. So originally we had a color solution. After having a color solution, after adding hydrochloric acid, sodium hydroxide, and finally Benedict solution, we have now a blue solution. So when you are writing, you tell us the initial color, which was a color solution. And then you tell us the next thing you tell us about the color after adding Benedict solution. That is after you have added all the other things and then Benedicts, you have a blue solution. So it means when you're writing, we say a color solution turns to a blue solution. You don't have to tell us about the other colors in the middle there. Then now we are going to say, what about after boiling? So come with me here. So I have a blue solution. Now what about if I boil? What if I boil here? When I boil, what do I observe? So when I boil them, when I get this blue solution and I boil it, what am I able to observe? What am I able to observe? What am I able to observe if I come and I make this mixture to boil? If this mixture comes and it now comes to boil, what does it give me? Yeah, so you see the mixture is boiling. Mixture is boiling. Yeah, from blue to green. Now it is coming to yellow. From yellow, you see, from yellow it is now coming to orange. Yeah, from orange, of course, I expect it to go to brown. The more you continue heating, I expect it to come and finally come up to brown. I hope you have already now appreciated that now things have turned. The other part, first when we added the just Benedicts and boiled, things remained blue. Things were remaining blue, but now after adding all those other things, indeed you see that something has happened. Something has happened. So you see that the solution is not like the way it was originally. I hope you can now see that things have changed. So the more you continue boiling, I'm trying to boil so that my 1 minute can elapse. My 1 minute can be elapsing. Yeah, I know some of you could be looking at your screen to ensure that indeed 1 minute has elapsed. Yeah, but I hope you can now see that indeed our things have what? Our things have turned. Have turned from the original color, which was blue, to a brown color. Yeah, to brown color. Yeah, I don't know if some people say this is orange. I hope when you check here, yeah, this is brown. This is brown. So hope you have appreciated indeed. Yeah. So now after having seen that, so we come back to our board here. We come back to our board here, and then we try to see what to write. So we are saying here. We are saying what have we observed? The observation we said when you write in the observation, you begin from the original color. So we had a colorless what? You had a colorless solution at first. Then it turned into a blue solution. Why? I've told you don't tell us about the colors that you get when you add this, when you cool, when you boil, when you cool, when you add sodium hydroxide. Those colors you don't need. Just to do like what they have told, what you expected to do. And then, but finally, you come. So this was the original color. Then after adding all these things and then Benedict's, you formed a blue solution. Then after, what happens on boiling? On boiling, what have we observed? On boiling, the blue solution turned, remember we are reporting, turned to a green, I told you these colors are, they go in line of blue, green, yellow, yellow, and then brown. So we are saying on boiling, the blue solution, we have seen this one together, that on boiling, the blue solution has turned into a green solution, then into what? To a yellow. I told you that blue and green, these are solutions, these ones are all precipitates. Yeah, so it was blue, green, yellow, and then I told you before brown, we have orange. We have orange, and from orange you come to brown. Sorry for that. It was an error. So from green solution then to a yellow precipitate, then to orange precipitate, and then and finally to a brown precipitate. Yeah, so this is what we have been able to observe. So all these ones here, a colorless solution, yeah, blue solution, you're able to observe that color. Then after, on boiling, you have been able to see green solution, yellow precipitate, orange precipitate, brown precipitate, and all that. Yeah, so depending on what you have observed, that's where you stop. If you are stop on yellow, you stop on yellow precipitate. If you are stop on green, you stop on green precipitate. Now, the fact that we have seen all these up to brown, I told you, if they stop on green, that is little. Yellow, that is moderate, reducing sugars present. Orange, that is much. Then this is too much. So, because we have seen all these colors, I want to take note of how we write the observation here. For the case of non-reducing sugar, especially for somebody who is in advanced level, take note of how we write the conclusion. We don't just simply come and say non-reducing sugar is present. No. From what we have seen inside here, we have seen that we first added this hydrochloric acid to hydrolyze the non-reducing sugars into reducing sugars. So when you come here, I expect you to say, here, since we have got brown, we expect to say too much non-reducing sugars present. But we are supposed to write like this. We are supposed to say that we have too much. We are supposed to write like this. Too much reducing sugars present. Too much reducing sugars present. I know somebody is there saying, hey, teacher, you stop lying. We are testing for non-reducing sugars. Why are you saying too much reducing sugars present and we are testing for non-reducing sugars? Yeah, please relax a bit, we are coming. So we are saying too much reducing sugars present. Why are they present? Yeah, of course, this Benedict solution for it tests for reducing sugars. If the reducing sugars are not there, then it will not do anything. So this Benedict is actually a chemical test for reducing sugars. That's why we had to add these chemicals. We had to add all these chemicals to ensure that the non-reducing sugars are turned into reducing sugars, because Benedict's only test for reducing sugars. So we say too much reducing sugars are present. However, because it is a test for non-reducing sugars, we shall say this too much reducing sugars present, but we shall come and add from hydrolysis of non-reducing sugars. Yeah, it means these too much reducing sugars have come from the non-reducing sugars. And then we shall come here and say thus, or hence, we shall come here now say hence, too much non-reducing sugars present. So if for you wanted me to just come and say too much non-reducing sugars present, for you can write that. But I'm saying the best way or the better way to write it, it is writing it in this way. That too much reducing sugars were present because of all these colors. It means that we had too much reducing sugars. But those too much reducing sugars came from hydrolysis of non-reducing sugars by hydrochloric acid, because we saw that when we didn't put hydrochloric acid and all these things refused to change. So it means we have too much reducing sugars from hydrolysis of non-reducing sugars. And therefore it means we have too much non-reducing sugars. When you have too much non-reducing sugars, when they are hydrolyzed, they also give you too much reducing sugars. And when you have too much reducing sugars, you see all the colors up to brown. I hope you have learned something. So it means if for you tomorrow you have another solution, or you have another food and you're testing for reducing sugars, and your colors, maybe you had a yellow, so you have a white solution. And then after a white solution, so assume for you had a white solution, and then a white solution turned to a blue, a white solution turns to a blue solution, then on boiling, the blue solution turns to green solution and stops there. You now to conclude. Or you can have a white solution turns to a blue solution. On boiling, it turns to a green solution. And then after it turns to a yellow solution, a yellow precipitate, and it ends there. You now to conclude. Or if you can have a white solution tomorrow, or you can get some food and get a white solution. And then a white solution turns to a blue solution. Then on boiling, the blue solution turns to a green solution. Then after it goes to yellow precipitate. Then after it goes to orange precipitate, and it ends there. So all these ones you know how to conclude. So from that sample here, from this sample you can now easily tell how you are going to conclude. So if you boil whatever solution you have, after adding Benedict's theta, after adding all these things and the Benedict's form a blue solution, then on boiling, the blue solution turns to a green solution and stops there, and everything stops there. And you continue boiling and things don't go beyond green. Then here you will say, of course, when it is green, we are supposed to say little. So here we say little reducing sugars are present from hydrolysis of non-reducing sugars. Hence, little non-reducing sugars are present. When it comes here, we shall say this is yellow. This is yellow. We are saying this is moderate reducing sugars present. But when you're writing it, you will say moderate. If it is a test for non-reducing sugars, you say moderate reducing sugars present from hydrolysis of non-reducing sugars. Hence, moderate non-reducing sugars are present. By the way, in case I'm teaching and then you feel like you have missed out something, you are free to, again, you can rewind this thing and you go behind and you go backwards and then you check for the statement I've just said. So even when we come here, it means yellow. I've said when you have yellow, that is much. So this is much reducing sugars present. But here, when you're testing for non-reducing sugars, you will say much reducing sugars present from hydrolysis of non-reducing sugars. Hence, much non-reducing sugars are present. So we have little, moderate, much, too much for brown. Little, moderate, much, and then too much for the case of brown. I hope in this case you have got. And then in case you're writing maybe in the new curriculum or for the ones who are in A-level, you write these things yourself, here you can turn this one into a reported speech. You are supposed to write this one in a reported speech. So in this case, you are supposed to say to 1 centimeter cube of the food or 1 centimeter cube of dilute hydrochloric acid was added and the mixture boiled. The mixture was then cooled. And then after cooling the mixture, 1 centimeter cube of sodium hydroxide was added, followed by 1 centimeter cube of Benedict's solution, and the mixture was again boiled for 1 minute. That is the reported speech. I hope that way you can be able to do all the other work. Thank you. Give me a like. May God bless you.